So this is a kind of an interesting moment in LLM. I have been advocating with Anthropic as well as OpenAI for some time, probably more than a year, across the meetings, even AWS, imagine AWS, for more than a year, just to bring them more into the life science. And finally, the company have started getting focused in there. That's very good news for me, for everyone, because at the end of the day, we have to take care of our patients. We want them to live because they are our family members. They are the people we live with. We love them, and we are among them. So we want them to cure the disease and have a healthy life. Either way, so Anthropic has released this actually yesterday or today. It could be any time by yours. So this is an announcement from them, and they were discussing what they have started with. This is the beginning point. Actually, I think in AWS event 2 months ago, sorry, 3-4 months ago, something like that, I was talking with them in details, and they are saying they are actually working on this area, and it is online now. So let's see what they have seen, what they actually have done. This is a good beginning. I'm a positive person, so I have to say this is the good beginning for all of us. So let's see. They had saying that we are several improvements in connection of life sciences. So what are the several improvements? So let's see. This is a short video. What you can do with this? Okay, I can go it later on. I don't mind. Making Claude a better research partner. Okay, that is good. So they're saying that they have done a test that understanding and facility with laboratory protocols. Sonnet has 4.5 had 0.83% score, while the human has 0.79. So yeah, probably better than human. That's good. Rick's bench, it has gone better. Okay, either way, that's fine. Everybody is good in their own parameters, so probably it's good or not. We'll give it a try. We'll see. So now let's go. Connecting Claude to scientific tools. This is a big document, so I don't want to go here line by line. So connectors. What is connectors? So if you go to the Claude and go to the setup, if you go to the Claude and you go to the setup in the setting, you will see it's a option for connectors, which gives you the connect with different things in here. So that's good. So Benchling, Biorender, PubMed, Scholar Gateway, Synapse, 10x Genomics. That's good. Developing a skill for Claude. Okay. So they are saying they are starting with the single cell RNA-seq QC, and that has been quality control and filtering with the SCBars. So all who don't know much about the SCBars, is a foundational model that's with a single cell multiomics data analysis. Better part could be there is SCBI tools. I have a couple of videos that I generated from a student, and it's little in there. So it goes through, it's probably was trained on that. I'm saying I can build their own thing. That's always good, including setting up custom skills like here. Okay, what is custom skills? Let's go. So using skills in Claude. Pro plans, you can go to the capabilities, skills. So let us try. So we go to the capabilities and we enable the skill. Okay, we can do a lot of skill upload. Artifacts builder, brand guideline, canvas. Well, I need to make it very clear in here is that this is a paid version. So it's a it's a payment version. It's a yearly version, so you have to pay money. I don't know it's freely available or not. It could be. I'm just not aware. So the skill is very important thing. I think so. And it has quite a weight. So if you what about the MCP, this is a model context protocol you can build up, and it will have the multiple agents under the main agent in LLM, and it will work individually. I can talk all this all night. That's not a problem. From the lunchtime till the whole night. If you want to have interest, just knock me. I'll be happy to explain. And you can build the, and you can there was something like prompt engineering earlier. So that was earlier, like a couple of years ago, you used to use. I have a couple of videos. You can just go to my YouTube channel and you'll find those. So these are a couple of the videos I have in here. These are, I don't know, 30 selected. I have more. Could be. Okay, 39, not much. But this is for single cell sequencing, bulk RNA-seq sequencing, different types of prompt engineering, a lot of things. I just did it. I mostly trained them for my students, so I can't tell you that in details right now. But if you go through this, there is a video on prompt engineering. So if there is a search option, let me just prompt engineering. Okay, so this is uploaded in 20. Sorry, so this was the video. This was uploaded in the December 2023. So it's been some time, almost close to 2 years actually. So if you go in here, you will see efficiently. So this is the language that AI understands. So prompt engineering. Now, when you are going into the MCP or model context protocol to do your work in a state of view, and you can really make the fantastic things in here. So what you need to do in there is that specifically that you need to do the model context, the context engineering. So that is a different thing. I was thinking to make a video, but unfortunately I cannot manage enough time to do it. But it's very important that because when you are running a model, an MCP model is running, so it's like a whole thing, like an institution, and it can get lost anytime. So that's not a good idea. So better way to give it an instruction that how much fetching it will do, how much information it will keep. It will make a rolling sheet of information. That's important, so that it doesn't get lost into the universe. It has to be focused, trained, and to do your job. So that's another type of engineering you need to know. I can explain it different time. Just send me an email. It's like I have uh, my, okay, if you search my name, it's better. So just you can search me somewhere in here, probably. Okay, it was in either way. It was in here. That's probably outside. I think it's in. So, okay, so this is just one. You can send me email with my email. It's like with this. After that dot at the rate of mssm.edu. But either way, that's not important. The important point in here is that's the way you need to run the model context protocols in there with the LLM. That's not focus of today. Let's get focused. Okay, so you get to run with this, and then you can do the custom designing of the skills and everything. Now using Claude for Life Science, so they have this fancy videos which is great, generating protocols, slides, bioinformatics analysis, everything they said in here. So that's another And they have created a library of prompts. So what is a Claude scientific benchling, 10x genomics, these things, and here you can go in there or skills. Let's see what they have in here. Okay, these are the basic, I would say, very basic things that's in here. So I would not be really fascinated with this. I would say this is just the beginning, and there's a long way to go. So these are their license things. If we go to the, let me just put it in by, I don't know how if we can connect it with the license. Just put it. I'll create a fork in here and probably can. Okay, it's probably will help me to keep the meta track, otherwise I'll forget. So this have some documentation in here, and you are welcome to go through. I would say like single cell RNA seq with this scan-p. So if you go through my GitHub channel, you will find GitHub code block. You will find a lot of repository and my own software. So they have written a lot of them in here that has bulk and single cell clear instruction, step by step doing it. I hope they will also use if they want to, but I don't know. I have. That's a different issue. If they want to, they are welcome. If not, they are also welcome. So let's say there's now it's a core analysis plotting. Okay, let me see what does it say. And data scan. Oh, this is a copy paste from there, so there is not much actually, but that's fine. You can see it in here. Default met counts. Okay, mitochondrial count. Okay, this is nothing more, but hopefully they will improve. Some stack. Okay, the QC core. Okay, let's see what's a common separated mitochondrial count. Okay, default outliers. Okay, hard order. Okay, print QC. Okay, yes, like not say much, but if they say so, I don't know which experts they worked with. Who is the developer? Could be great. He has a subject specific knowledge. Could be, or could not be. Who knows? Either way, this is their headache. So I was coming in here. So partnership and customers, they have partnership with some institutions, which includes a lot of them. And Cloud of Lab Science, what is that? Is it something that's customized in here? Let me try. I know that's the same thing. So let me just try. They are saying that they have already collaborated and they have connectors with the 10x genomics. They have with the PubMed, which is fantastic. Let me give it a try and see where does it goes, right? So let's see their performance. Let's see there. Sorry. Let's see how this did do. So this is a project. Okay, let me try with this. First, let me see that do you have in the connector. They said that you will have the 10x genomics, right? They have the connector. It was saying in here. We have the connector. So let me see where is the connector. Connector at the end of the day. They say they have connector, but where is it? They have a fancy advertisement that does everything. So let me just try it because they say they have everything in connector. So new connectors allow Claude to access other platforms and tools directly. So let me see, does they have any connector? Browse. Let's see. PubMed is there. I'll add a PubMed. PubMed is very fancy, and I use it almost all for the day, so I don't mind. I don't see. I mean, I could be missing, but it doesn't look like I'm missing. They don't have it in here. Probably will be available later on. Who knows? Byron is here. That means the desktop connection, open Claude for desktop. Okay, so they have a connector for desktop. This computer doesn't have any Claude for desktop, so let me just try with. So I don't know. I use the Ubuntu system, so I don't have any idea. Like I don't have a Windows system, so I can't speak about how does it, how good or bad it is with that. So it provides certain limitation, but I can try to open it on my. Well, just for this purpose, I have installed the. Just to show you a demo, like this. I have installed this Claude in here, so let's see where it goes. So you can see there's a connectors option in here, and you can okay browse connectors. So they have 10 in here. Let's see if they have. That's good. I don't think so. Desktop extension. Okay, they probably have it here. Yeah, luckily they have it in here. I'm just testing and to show you guys. I'm never going to use it in my computer on this way. So I have to give a token, and then I can upload my files in there, and then when I upload the file, it can take the files from analysis from there. So that's the whole process. I don't want to do it in here, so I'm sorry. So this will be uninstalled from there. That's fine. It's official computer, so I don't want to mess up with the things. Either way, so you have it now, for example. Now what can you do with this? That's the point. So you have installed in, and when I have the connector account PubMed, so you need to configure this thing. Always ask do whatever you want to do. I don't care as long as you do my work. I don't know, I'm doing it for guys, so I'm not that fascinated with all those things. So now we have this connector. Let's say, so I will the way they have shown the demo. Let's see how much it works with them. So as per their demo, they were showing earlier that you can go through this and you can do a lot of analysis and everything with this. So let's follow their demo. Like, let's see. So 10x website will upload the file, and then 10x Cloud will run our data. So it's like that. So let me show you there also. And want you to run through the damn thing without knowing what you are doing. So for example, I have a lot of data in here. So let's say, okay, we have this data set. So from here, I download one of them. And let's upload and see how this it works in there. Like that. So we'll upload one of them and then upload it there, and we'll see that how does it do, or what are the suggestions it has for the data analysis. So let me just upload 2 files in here and see how does it work. So usually when you get the data set and we load them from the 10x Cloud, then we'll see them in different versions. So we'll do the initial filtering and everything. I have the algorithms. It's probably one of them is open now. There are many of them, like there are a lot of them in here and there. So for example, like so let's say this is one of the algorithm. So you have the filtering parameter, so you have renaming filtering parameter. You go through the figures and we see what is the parameter setup and everything. Then we get the save the files, and then the SCBA algorithm was used to annotate different cell types and everything. So let's see if we upload to a couple of files in here, and does it or is it able to actually do anything. So let me just try to upload 2 of them. Will it take, or nope, it doesn't take any file that's more than 31 MB. So I can't, all my files are like up to 150 or 200 MB. So let me write a I'm not using any property, just guys straight coming to the point. Peripheral blood molecules and data. Sequence. Follow. State. There is always options like what you want to do, your style. You can connect with the GitHub. You can do add connector, a lot of things. Let's see, what does it say? Donor and Milo fibrosis patient samples. So you can simply select it and let's see what they say. There's the thought process of the machine, then what does it say? Because I was very specific, so the folder will go in there and then to write the code and CT3, okay, DPI 300 is fine. So sample path in there, it will load the samples, mitochondrial count, gives matrices. Okay. I'm not going into judge it, but there are a lot of things that need to be initial ones that need to be optimized. I just don't want to go in there. This is a Surat version 3. That was very early training of a Scanpy at the very beginning version. So they are just following it. There are a couple of tweaks that's required to be done, but they are just simply doing it. It's kind of a direct copy paste from here. Scanpy protocol. Scanpy tutorial. So what they are it's showing in there is just direct copy paste from here. That's all. That's it. It's not going through anything new. So either way, that's good for it. But it's efficient to write it as Sonnet 4.5 version is good in terms of running the long term, rather than the Opus used to take a lot of space and more work limited, but this one is comparatively better. Now let me just find some data as DEGs from there, and then what are the cell type annotation software or algorithm you recommend best in Jupyter notebook? Because most of the cell type annotation tools are black boxes, so it's better to have it something more substantial. So let me just follow it. I had some instruction in my profile, so it's probably following that. Top tier cell typist, but it's a black box. So I don't know, like what it will like it or limited to available model, less flexibility. SCBA and BI. Okay, that's a good one. It's a lot of model, man. So this is one of the model that because I was a laboratory scientist as well as right now also. So I would recommend to use it because it is designed. You can change the gene name and do the customization by flow cytometry. So I would recommend this one for my it's written for me by me. It doesn't matter. The important point is that it has a substantial merit that makes sense in terms of as a biologist, but people could have different opinion. That's all right with me. How many of them they are rating? Running cell typist. Okay. It's just come on, man. You don't need. I didn't ask you to write it down. Either way, so you have it. Now what will it do? We will go through the we'll go through, we'll upload it to DEGs and see that if we ask it to compare it, how does it does. Let me just, so let me just go through this and get some data sets. That's so we can go further. So let's go through this DEGs. Okay, what does it say? Absolutely black box are so difficult to understand. So it went through this. Well, it's overstating in here. This is list change actually. But either way, if they think so, it thinks so. And yeah, it took the code from the GitHub very well, which is good. So okay. Come on, man. How much do you want to type? Okay. Is 4-star inductive speed? Come on, man. Speed 4-star is not true. It takes 5 seconds or actually 2 seconds. It should be 5-star, but yeah. That's fine. So interpret with transparency. Okay, it looks like finally it started recognizing. Well, that's fine. So what I'm doing to do now we have this DEG list. We want you to comprehensively analyze the pathways those relevant to it, and then make figures finally or PDF. Let's see what it does. CSV format is not supported. Okay, CSV format is not supported. I will make it Excel. No problem with me. Text document, spread presentation, XML, HTML. I'll give you the Excel format. No problem. Text document levels template. I don't know which one is what. I have an Excel document. Okay, that's not good. Just a second. Sorry, spreadsheet. That's probably it. Save as ODS. Nope. XLSX. Okay. I'm just saving it somewhere. Downloads. DGs off. To poetic stem progenitor cells. Okay, so I made some copy of it. Let me just upload that recent and upload it. This is so bad. Let me just give me a second. Okay, so let me try. Come on, man. means you don't take the CSV, you don't take this, or what the hell you take. I need to take the data, right? Okay, either way, I'll then copy. I'll just copy the data set to. Okay, that's not good. Let me just make a filter in here. Filter, then put a filter in here. I don't want it to be less than 0.05. Okay, so let's see how much it does. Let's see what is my next meeting. Sorry for this. Let's run 15 something. Okay. Write the code only. I'd ask you to ask you. By yourself. Let's see. It can do it or not. Okay, let's see. Let's see the steps. It's getting into agentic mode. It's exciting. I don't care about the slide. It doesn't come later on. First, do the analysis. Use MongoDB or something like that. Let's see how does it do. Well, for your better understanding, I have been trying with all the companies for a long time to bring them into the journey, because this is the core of the clinical innovation, and they have to be very focused on this. Now they have started, that's a good news. How much they have done it, that's a different news. I'm not pausing the video. It's one of the reasons that I want you to see how it is doing it. If not, we will use the Claude code. It's impressive. Looks like they estimated the figures. Come on, man. So there was an error. That's bad. It's installing somewhere. Oh, npm platform. It's installing HTML to PPTX. Okay. Well, irrespective of the way I was trying my best, but still it doesn't. I tried trying again, but it doesn't do it by itself. It's just generating the code. So I don't know what to say. It's probably something I'm missing, or I need to do the install in here, or Cloud or Web will be better. Sorry, Cloud or Code will be better. I can't say it's not working. So it's just a code generating in there. You have to run it within computer that I can do from CLI or in the Jupyter notebook or wherever I want. So that's not the problem. The idea that was shown in there here was that you just run it in there. The video demonstration shows you run in there and it does all things by itself, generates figures of everything. But level on the figure, it's not. I know that you have BioRender and others, it will do it. I understand that, but you need to generate something in here. It cannot install within the npm. It cannot install PowerPoint or something, or I don't know what is the issue. So either way, this code should work. That's the point. And if it works, then just let me get the genes, couple of them, and see like can it go to the path through and see that which genes are what. Okay, so this was the gene list. So I'm going through this gene list. Keep writing, keep writing. So one of the reason is that it generates a lot of wrong. Just giving a part time. Wrong references. It makes up references by itself. So to resolve this, not that high. Earlier hallucination rate was really high. So let's see how good it is in here. So this is one of the another issue. The problem Cloud, that's this. It does lose your maximum length of conversation pretty soon. So you have to start a new one. This is not the best thing. So let's just start it. Please continue the discussion from earlier conversation. Let's see. But it's a good thing they have added a couple of days ago that you can continue the uh, conversation from previous conversation. You can search it and give it name. So I would suggest you quote that specific conversation, which was the last one, and what are the tasks in there. Let's see. It didn't. So not. It should start from here. So either way, this conversation. This is what I'm scared of this. Session limit search. Either way, this is what the entire picture is. I can't, it's definitely not up to the mark that they have been telling us, but as an independent person, I can tell that I don't know, like so it's up to them, but it can be, it's a good beginning, that's definitely, and I'm happy to help anyone interested on the including companies and individual to the context of bringing this entire AI into the area of genomics. If you need my introduction or anything, just look for myself in here. You can send me email. Let me just say, okay. So you can just send me email on like this, md.me@mssm.edu, and I'll be happy to help in any integration of drug discovery, single cell genomics, some DNA, RNA, protein, any of them, attack any of them, and anything that you need. Okay, take care. Bye.